Semiconductor manufacturing involves a wide range of highly specialized instruments and tools. Here's an overview of the main types of instruments used in the process. 1. Photoorthography equipment. Stepper, scanner, projects circuit patterns onto silicon wafers using UV light. Mask aligners, aligns photomasks with wafers in older or less advanced fabs. 2. Etching tools. Reactive ion etching, RE, uses plasma to etch fine features into wafers. Wet etching equipment, uses chemicals to etch materials selectively. 3. Deposition systems. Chemical vapor deposition, CVD, deposits thin films using chemical reactions. Physical vapor deposition, PVD, includes sputtering and evaporation systems. Atomic layer deposition, ALD, offers precise, atomic scale film deposition. 4. Ion implantation tools. Inject dopants, impurities, into wafers to modify electrical properties. 5. Chemical mechanical planarization, CMP, tools. Polishes wafers to achieve flat surfaces for multi-layer stacking. 6. Wafer inspection and metrology tools. Scanning electron microscopes, SEM, for nanoscale imaging. Atomic force microscopes, AFM, for surface topology. Critical dimension, CD, measurement systems, for line width accuracy. Ellipsometers, for thin film thickness measurement. 7. Cleaning systems. Wet bench stations, use chemicals like HF to clean wafers. Megasonic cleaners, use sound waves in liquid to remove particles. 8. Dicing and packaging tools. Wafer dices, cut wafers into individual chips. Die bonders, wire bonders, assemble and connect chips. Encapsulation machines, seal the chips in protective packages. 9. Test equipment. Parametric testers, measure electrical characteristics. Automated test equipment, 8, for functional chip testing. As of 2024, the top 5 semiconductor manufacturing equipment suppliers, ranked by revenue and technological leadership, are 1. ASML, Netherlands. Specialization, photoorthography equipment, particularly extreme ultraviolet, EUV, systems. Market position, ASML is the sole supplier of EUV lithography machines, essential for producing advanced chips at 7 nanometers and below. 2024 revenue, over $30 billion, leading the global semiconductor equipment market. 2. Applied Materials, USA. Specialization, comprehensive semiconductor fabrication equipment, including deposition, etching, and inspection tools. Market position, known for its broad product portfolio and innovation in materials engineering. 2024 revenue, approximately $25 billion, ranking second globally. 3. Lam Research, USA. Specialization, etching, deposition, and cleaning equipment for wafer fabrication. Market position, a key supplier for advanced semiconductor manufacturing processes. 2024 revenue, significant growth, maintaining a strong position in the top 5. 4. Tokyo Electron, Japan. Specialization, coaters, developers, deposition tools, thermal processing systems, and etching equipment. Market position, Japan's leading semiconductor equipment supplier with a global presence. 2024 revenue, continued growth, securing the 4th position worldwide. 5. KLA Corporation, USA. Specialization, process control and yield management solutions, including defect inspection and metrology systems. Market position, dominant in the semiconductor inspection and metrology segment. 2024 revenue, strong performance, rounding out the top 5 equipment suppliers. In the semiconductor manufacturing equipment (SME) industry, the distribution channel is highly specialized and differs from typical consumer electronics due to the complexity, cost, and technical support required. Here's a breakdown of how distribution works for companies like ASML, Applied Materials, Lam Research, Tokyo Electron, and KLA. Typical distribution channel structure. Direct sales, primary channel. Major OEMs, original equipment manufacturers, like Intel, TSMC, Samsung, and GlobalFoundries buy directly from equipment vendors. The transaction includes not just the tool, but installation, customization, training, and ongoing support. This channel accounts for the vast majority of sales due to high value of individual transactions, millions to hundreds of millions per unit. Need for deep integration into customer fab workflows. Strong confidentiality and collaboration on future node development. Regional sales and service subsidiaries. All top equipment vendors operate regional subsidiaries, e.g., Applied Materials Japan, Lam Research Korea. These offices handle localized sales and marketing, customer service and maintenance, spare parts logistics, technical consulting and training. This structure helps vendors maintain tight relationships and respond quickly to fab requirements. System integrators, strategic alliances, limited use. In rare cases, vendors partner with system integrators for emerging markets, e.g., India or Southeast Asia. Mid-size fabs that can't afford full-scale direct vendor support. Example, working with foundry builders or government-funded semiconductor initiatives. Aftermarket and refurbished tools dealers. Older generation tools, e.g., for 28 nanometers and above nodes, are often sold through secondary markets. Companies like Rena Technologies, telephone used equipment, and surplus dealers refurbish and resell. Buyers include smaller fabs, universities, and R&D labs. Key enablers in distribution. Field service engineers, FSEs, crucial for installing and maintaining equipment. Customer support agreements, CSAs, long-term support contracts for uptime guarantees. Parts and consumables supply chain, real-time logistics to avoid fab downtime. Fab integration teams work directly with customers during process development and ramp-up. Summary table. Channel used by purpose direct sales ASML, Applied, Lam, etc. Large volume, high-tech fab customers, regional offices, all top 5 vendors, local service, support, and SALA system integrators, limited. Some emerging markets help with setup in non-core regions, refurbished equipment dealers, older tools for small fabs, R&D, lower cost access to legacy equipment. Let me know if you'd like a visual diagram of this distribution model or if you're focusing on a specific vendor or region. The major customers of top semiconductor manufacturing equipment, SME, suppliers are primarily large-scale chip manufacturers and foundries, also known as integrated device manufacturers, IDMs, and pure-play foundries. These companies build and operate semiconductor fabs and invest billions in advanced manufacturing tools. Top major customers of SME companies. 1. TSMC, Taiwan Semiconductor Manufacturing Company. Customer of ASML, Applied Materials, Lam Research, Tokyo Electron, KLA. Y. World's largest pure-play foundry, huge demand for advanced lithography, EUV, deposition, and etching tools. Purchases: EUV scanners, etch, deposition equipment, metrology tools. 2. Samsung Electronics, South Korea. Customer of all top 5 vendors. Y. Major player in both memory, DRAM, NAND, and logic, foundry, production. Purchases: high-end fab tools for both memory and logic nodes, including EUV from ASML. 3. Intel, USA. Customer of ASML, Applied, Lam, KLA, Tokyo Electron. Y. Transitioning to leading-edge nodes, big investment in EUV and process control. Purchases: advanced lithography, process control systems, atomic layer deposition, ALD. 4. SK Hynix, South Korea. Customer of Applied, Lam, KLA, Tokyo Electron. Y. A global leader in DRAM and NAND production. Purchases: high-throughput etching and deposition tools tailored for memory. 5. Micron Technology, USA. Customer of Applied Materials, Lam Research, Tokyo Electron, KLA. Y. Focuses on DRAM and NAND memory. Invests in high-volume manufacturing tools. Other significant customers. Customer-Agents Specialty Global Foundry Asusa, Singapore Foundry for Mature Node Semiconductor Leading Chinese Foundry, limited access to EUV due to export restrictions, Texas Instruments Analog, Mixed Signal, Mature Node TSMC Taiwan Foundry focused on mature process nodes PSMC, Vanguard Taiwan Specialty and Legacy Node Fabs. Note on confidentiality. Many equipment orders are under NDAs or made through framework agreements, so exact customer tool pairings are sometimes undisclosed. However, public financial disclosures and industry reports provide a clear picture of these major relationships.